Okay, so let's talk about ecological succession. What it is. What is ecological succession? Ecological succession is the regular way in which ecosystems respond after being disturbed, after having their vegetation removed. For the most part, you would think, oh, well, like when you disturb an ecosystem, it just goes back to where it was before. And it doesn't. It follows the same general process where it goes from pioneer to intermediate to climax community. But at the end of your ecological succession, you're going to have a community that's very different than the community that was disturbed. So we're going to talk about what happens all along that path. So there's two main types of ecological succession, and they're different based on the intensity of the disturbance. So primary succession takes thousands of years to occur, and it happens because there's a disturbance that completely removes the soil, and what you're left with is bare rock. So not only do you have to restore the plant and animal community that was disturbed, but you also have to restore the soil that was disrupted. So here you're going to see something very different than what you had before the disturbance. We'll talk about that in a little bit more detail in 2 slides or so. Secondary succession happens over a shorter period of time, generally 1 to 200 years after a disturbance. It is able to reach climax community unless it has been disturbed again. And the disturbance isn't as intense as your primary succession. So you don't have complete removal of the soil, you just clear the vegetation. So you don't have to completely restore that soil and break down rock. You just have to restore the plants and animals, and that's why it takes not as long as primary succession. So regardless of primary or secondary succession, you're going to have the same 3 stages, the same 3 steps of succession. You have pioneer species, followed by, which are really good colonizers, followed by intermediate species, followed by your climax community, which are your really good competitors. So let's take a look at those steps. So the steps of succession, you can think of them as like steps in time. Also, they're very dependent on the amount of soil, the amount of nutrients, and the amount of light. So first you have your pioneer species. These guys are really good at breaking down bedrock. They're really good they're really good colonizers. So they're able to handle really stressful situations, full sun, no nutrients. Sometimes if we're dealing with primary succession, no soil. Generally, these guys are lichens and mosses. If we're dealing with primary succession, in secondary succession, our pioneer species are going to be annual plants. Once your pioneer species have been established, then you have your intermediate species, and these guys are grasses, small herbs, and shrubs. They're okay colonizers. They're not able to come in when there's full sun, no nutrients. They need a little bit of soil. They need a little bit of nutrients. So they need those pioneer species to do their job to facilitate them being able to survive in order for them to come in and colonize, but they need full sun. So they're okay colonizers, but they're still not great competitors. So they're called our intermediate species. And regardless of primary or secondary succession, these guys are shrubs and small trees. Our climax community are our big trees. These guys are really bad colonizers because they have high requirements. They require nutrients, they require soil. So they're not going to come in at the pioneer species level. They need soil, they need nutrients, and those nutrients are given by those pioneer and intermediate species breaking down the soil and releasing the nutrients that's stored in the rocks. But they're very good competitors. So they're shade tolerant, and they're able to once those requirements are there, they're able to reproduce faster and use more of the resources than intermediate and pioneer species. How does primary succession differ from secondary succession? So primary succession is a type of disturbance that completely gets rid of the soil. So you're left with bedrock. Hard for most organisms to live there, so we need lichens and maybe small annuals to start breaking down the rock before you can get soil where other plants can live. The type of disturbance that would cause primary succession are types of disturbance that completely rid the vegetation of that topsoil. So we're talking about glaciers, where you have a big sheet, a frozen river basically moving down the side of a mountain, carving out that bedrock. So when they recede, you end up seeing solid rock. A really great place that we can actually see primary succession happening right now is with all the warming that's going on. A lot of the glaciers are receding, and you can see primary succession in action. You can see at places very close to where the glacier has receded, you have bare rock. And then as you get farther and farther away where the glacier used to be, you can see the lichen, you can see the small grass as you move away. So we're actually getting to see the steps of primary succession right now in places where the glaciers are receding. So if that's something that interests you, head out to Glacier National Park. The time to reach our climax community, 500 to like 1,000 years. It takes a really long time because we have these lichens and moss that have to break down the rock to get the soil in order for other organisms to come. So it just takes a lot longer. In secondary succession, we don't disrupt the soil. We just clear the vegetation. So we don't have to deal with lichen and moss coming in and having to break down the soil. So it has a much shorter time frame. We're talking 100 to 200 years to climax community. And how we get secondary succession generally are fires, floods, maybe you clear land for pasture. That's generally secondary succession. Things that are the same, they go through pioneer, intermediate, climax communities. They follow that same general trend, but every time you go through a disturbance, your end ecosystem is going to be different than the ecosystem that you disturbed before it. So what affects these rates? Because they're not always the same. Different environmental conditions, of course, are going to affect the rates, but I want you to think about how the plants and animals that are colonizing these areas will affect the next level. So this has to do with what I want you to be thinking about here is how every time succession occurs, you end up with a different plant community. Every time there's a disturbance, you're not going to get the same community that you started with. And these are the reasons why. You have organisms that come in that increase the survivability of organisms that come after them. So that's called facilitation. When one species increases the survivability of others. Think about things that are they're helpers, right? Earthworms, they add nutrients to the soil. Trees, shade seedlings. So if you look over at the right, I have this table. It says presence of species A creates shaded areas for species B to grow. So it makes species B, it facilitates species B's growth. They're called facilitators, facilitation. So if you have the introduction of a facilitator, you're going to end up with a different group of organisms potentially. In inhibition, the presence of a species inhibits the growth of others. So there are certain pine needles that increase the acidity of the soil and make the soil less conducive for growth for certain organisms. And there are some seeds that when they germinate, they release toxins that prevent germination of other seeds. So these are organisms that prevent the growth of other organisms. That's called inhibition. That will change the community structure if those species are there. So if you look again at my little examples, the presence of species A creates a shaded area, and now species C can't grow because it needs sunlight to grow. So preventing species C growth. And then tolerance is plants in the later stages of succession succeed because they're no longer in direct competition with others for key resources. So they don't need those resources. So presence of species A creates shaded area, but species D doesn't necessarily need shade in order to survive. It doesn't need that condition that species A provided for it. So it's not competing with it, they're just dealing with something else. So a competitor is going to be competing for resources that maybe species A doesn't need. And that is ecological succession.